welcome everyone to the thing, and then I am going to throw it to you for introductions.
Awesome.
Hello everyone, welcome to the Developing for Smart Tabletop with the Blinks game system. First workshop of the day here at Playcrafting's Global Game Jam 2021. I'm Dan, I'm the games lead at Move 38, and this, is on that side of the screen for you. This is John.
Hey everyone, John here. I'm super thrilled to be starting the morning. Also, happy Global Game Jam. I'm just going to give a quick intro of what Blinks are, and Dan's going to be running this workshop today. So we're going to get into it pretty quickly. But if this is your first time seeing Blinks or hearing about Blinks, I want to just show you what they are. So Blinks are the world's first smart tabletop game system. It's created with these intelligent game pieces. Each one is a little hexagon that has magnets on all sides. They respond to touch, and they communicate with their neighbors. I'll actually switch over to a little top-down view. And each one of them knows a different game, and they're programmable, so you can make your own games. And so this weekend, if you're working with us and working with Dan, you can be making games, and you're going to learn during this hour how to make a game. And so I've got a little demo game on here. It's kind of like Pong for Blinks, where this game's called Dark Ball. And each time I hit the side with the paddle, the ball goes shooting out. And it's the person's job on the other end to hit the ball back in just the right time. But if you add more blinks to it, you can play this game solo, kind of like let's see, there we go. Kind of like hitting a tennis ball against a wall.
I really like this game solo, especially if you create a really weird web.
Yeah, and it can go crazy. So if I do something like this, who knows where the ball's going to go? And then if you want to load a new game, all you have to do is grab another blink. So this one's called Treasure Tumble. And I hold it down for 3 seconds. And when I introduce it to the other blinks, it finds all the other blinks and teaches them how to play. And so you're going to be seeing that process happen a lot today, because Dan's going to be writing new code and then just teaching it to all the blinks. And
And I'll be doing that in a couple of different ways as well, just to show. Oh yeah, please show that. Yeah.
So this is the Blinks game system. It comes with 9 blinks and 9 games, and all the blinks we ship are open source and reprogrammable. And right out of the box, the 9 games you have can be repurposed to play an infinite amount of games. And I think without further ado, Dan, show us the dev tools.
Yeah. So let me switch over to my. I'll explain this later. My Blinks camera. So here's my desk. This is where a lot of Blinks stuff gets made, especially during the pandemic. Hold on. I'm gonna move my camera setup, which may or may not be built out of Legos. So I've already opened it, but I've got our Blinks dev kit here. I've opened it. There's a little guide. And I've already taken some of the cords out because I have set them up and plugged them in. So I've got this programmer, and I've got this special developer blink. Right, John probably has one of those as well. And so, let me turn these all on. I would be able to, while I'm programming, which we'll show you in a minute, install straight from my computer into this blink and have this blink automatically teach all of these blinks. And so it makes development super fast. I've been working with blinks for like 3 years now, and this is the fastest, best way to get something on a blink. I used to use a dedicated programmer, which meant I had to very carefully line up these pins with the holes underneath the batteries, and now I don't have to live that life anymore. We're going to be using this developer kit today. But pretty much everything we're doing could work with the pins I just showed you. But I'm going to be using this just because it's faster today. And before we get started, I know we've got a lot of people in chat. I wanted to sort of say hi to everyone. Thanks for joining us. Some familiar faces. I know Bruno from our developer community made some amazing games on our developer forum. and some just amazing things to push the platform forward. And John, I think you know someone else on here.
Oh yeah, well I see we've got the coding train with us this morning, and ready with the developer kit in hand. And so this is going to be pretty cool. I think one of my favorite ways to learn to code is actually watching other people code online and learning from their best techniques. And it's cool. And in under an hour, you get up and making your own thing. And the coding train is no stranger to that.
Yeah. So we're going to start with, we're basically going to go through what I would call the sort of tutorials. We have some tutorials on our Blinks developer resources, but I'm going to go through the basics of them now, and we're going to build a little, I don't want to call it a game because I'm going to leave it up to the chat to make suggestions, and if you end up making an art project, more power to you. But real quick, I want to show you two things. I'm going to go into here. I mentioned the tutorials. We have a new, brand new, shiny Blinks developer resources. So this is where you're going to want to go for all this information after the chat. But tutorials are in here. And I am actually going to start this programming not on real Blinks. I am actually going to do this initially on the simulator, which is also a new sort of release from us. And I think John, a friend, who made this? I was not, yeah.
So the simulator was built by Cheyenne, a friend of Move 38's, and this was a project that he took on. He loved what we were doing, and he was like, I kind of want to see if I can create something that helps people iterate on games even quicker. And we sat down and had some ideas on what would be a natural interaction to kind of simulate this. There are a lot of really interesting questions. And so, this whole tool is in JavaScript, but it interprets from the Blinks library. And what you can see Dan doing here is I realized since it's difficult to simulate what magnets do on a screen, we created this a gesture where you draw a line and it splits them. It's kind of like you cut them. And then you can drag each of those clusters around and attach them. And, you can load up the different code. It looks like Dan's has no code in it right now.
Code in it right now. Also, John, it looks like I've lost your video on this particular screen.
That's okay. It'll just be the announcer voice.
Yeah. All right. So. Oh, interesting. Okay. So here's what we're gonna do. I'm going to start with what I think is the most basic, most important function of Blinks, which is making them light up. This is the way that you're going to communicate with your users. Your game is going to, of course, have these lights, and the library that John and Josh built makes this super easy. So I'm going to make code that doesn't even do anything. I'm just going to make something that makes the Blinks red. So that's set color, red. Red is a predefined color. We have a set of colors that we call system rainbow: red, orange, yellow, green, blue, violet, white, and off. And I can run this code, and now they're all red. That's all this code does. Set color red. I can also, let's say I want to do just one face, not all six. Now we're going to set color on face, I don't know, white. And there are 6 faces to a blink, and because this is programming, they're numbered from 0 to 5, not 1 to 6. That's important. That'll get you in trouble later. So let's say face 2. And let's run this code. And just like that, all of the face 2s of these blinks are now white. And I could drag it around, and the face obviously is independent of real world geometry. It's just a consistent position. And this is the basic way that you're going to do. This is the basic building block of all your visuals. There are a lot of interesting tricks you can do here, and we'll get into that later. But for now, set color is the whole blink. Set color on face is just one, and you specify. If you want to get real kooky, just gonna real quick, just a preview of things to come. I'm gonna do set color on face random 5, and that's gonna give us. Oh, hold on.
And so what's going to happen there?
I mean, it should. Hold on, I'm having.
So it's doing.
Oh, it's setup. You're right. Aha. See, John's better than this at me. Yes.
So this is perfect. I love seeing that because we've got two functions here. We've got setup and loop.
Yep.
And setup just happens once.
Right. That's what I was trying to achieve. So in loop, which runs every frame, what's the Blink's frame rate, you'd say?
It's about 30 frames per second.
Yeah, so about 30 times a second, it's choosing a random face and popping a white on that face. So this kind of, making random things happen, this is another way to do animations and do visuals. But for now, I'm going to turn this off because it's distracting. And now we have set color red. These are turning red every frame. So if you want to start to make a game, there are really two things you need to probably deal with. One, button presses. So the blinks have a single button on top. They could be single click, double click, triple click, quadruple clicked, long pressed. So you want to deal with button presses, and you also want to communicate with your neighbors to know if you have a neighbor or what that neighbor is saying. So we're going to start, and we're just going to do a really basic button press function. And John, just because I don't have the window open, give me a shout if anyone in chat has any questions.
Will do. I'm monitoring.
Okay. So to do button functions, again, it's all like really straightforward. So I'm going to ask the question, if button single clicked. This is a question I can ask. Sorry. I don't know.
Could you show us how you know what kind of functions you can write?
Oh, yeah. There is this wonderful list that is slowly opening. This is the Blinks API. These are all the functions that you can call on. Again, in the developer resources. So for instance, right now, I'm using button single clicked, which is this. This is the full sort of description and details about this function. And this function, if you're familiar with, sort of basic programming, it returns true or false. True if the button was single click, false if it was not. So I'm going to come back here.
And I think it's just worth pointing out, like, that's all the functions. So, like, you've got button down, button single click, button double clicked.
Button everything, Released, pressed, multi-clicked, button click count if you multi-click and you want to know how many times they clicked, long pressed, button down, all that stuff.
And there's a nice convenient back to top, right? Where we can...
Not this far down. There's going to be this. There is a small limitation to this thing that we use for our support documents that I am trying to learn to overcome. There's a small back to top thing I'm going to add. There will be.
Oh, got it. Cool.
Yeah. So, button single clicked. Yes if true, or true if it happened, false if it didn't. So, I don't know. Let's say if the button was single clicked, I'm going to set color blue. That's all. Sorry, I opened a new tab earlier because in Arduino, Control-T is auto format, and I just did it without thinking. Yeah, so I've run the code. It's red, as we expect. And then I click one. Is this not...
That's going to be pretty tough to see, right? Because you're only going to get it for 1/30th of a second.
This is the problem with me in the simulator is that I'm so used to. So, John, is there an auto format, or do I just hit tab? I'll just hit tab.
You just hit tab.
All right. So, blink start out as red, and then if at any point you click it, it turns blue. I'm going to drag this over. and now it's blue. And I could turn this one blue, I could turn this one blue, and this one. But I have no way of going back. So I could do this with any of the button logics. So I could change this to double-clicked. I could run this code. And a single click now doesn't do anything. It's not listening for that. But a double click turns it blue. Double click turns it blue. I could build a suite of separate functions. This one is single click. And so now I want that to be green. So now a single click turns it green, a double click turns it blue. And in fact, now that I've got both of these running, I can start double-clicking the things that I single-clicked and single-clicking the things that I double-clicked.
And Dan, I see a good question in the comments. So this is something I think is really neat, is you're writing code on the left, but the code, we didn't start with just a single one, but the code is running on each individual piece.
Yes, it's running on every single piece independently, which for this code is not going to come up, but that's an important thing about the architecture of a Blinks game, is that unlike when you're making something in Unity, where you have total command of everything all at once, and if you want to declare something true, you can declare it universally true, you can broadcast a message to everyone. That's not the case on Blinks. Each blink is independently running this piece of code. So you can't just say, everybody turn blue, because you'd have to press every button. Like, each one needs to be individually told to turn blue. So if you want to do something like everybody turn blue, it's actually a very different process, which we'll get into in the communication thing. But it allows for some really fascinating organic behaviors that would be very difficult to achieve in a system like Unity or Unreal, where you're sort of acting as a sort of god that can just command things. So you can get really cool organic behaviors.
Awesome. Yeah.
So these are some basic button clicks. Before I get into communication, which is going to take a little longer, I actually want to kind of whose line is it anyway this. Oh, hold on. Oh, so could you make it? I was going to say, so Supercrafter 100 is asking a question here. Is there a way to make it so only one blink is available for clicking? Kind of. You could designate a blink as the prime blink, and I can make something like that. And maybe that's how we'll start. But what I want to do is ask. I'll give everyone, I know there's a 30-second lag, what's a basic game idea we could make? Because I could sit here and put functions in, but I think it'd be more interesting if sort of we get some ideas of like, oh, make a game where you click this and this does this and that kind of thing. And that will sort of guide what functions we put where. So while we let people whose line this, go ahead, John.
Yeah, and I think to that point, I mean, I think the question was, typically on a computer, if you say if button single clicked, everything knows the button was single clicked.
Yeah.
But what we're not, and it's really obvious when you're holding the blinks in hand, that this one over here doesn't know that this one was single clicked unless we let it share that.
Right. Unless we communicate.
And so I think actually what the question was asking for is already actually implemented. Mm-hmm. When you say is button single clicked, the one you clicked on responds to that. The other ones, no idea.
Mm-hmm. So we've got some suggestions coming in. We've got Game of Life, which Manthan, that is a great suggestion, and also part of the inspiration, I think, for Blinks itself, right?
Yep.
And there's some there's a stream we have from the past that I'd recommend you watch. There's a stream where we discuss Wham, right?
Uh-huh.
Yeah, Wham is one of our like sort of core games, and it secretly has the Game of Life running in the background at all times in a way that is unnecessarily, not at all times, at many times,
Oh no, I just mean it's sort of Game of Life.
It's heavily inspired by Game of Life, but it allows for a really cool type of randomization. But so we've got Game of Life and we've got card draw. So these are the two suggestions. So I'm going to take a minute and think about how we can mesh these together for something simple and interesting to build. So the premise of the Game of Life is that everything moves in steps. I think what we could do is make a game where when you click, the world steps forward, and we'll have the stepping forward be that each blink moves on to a new card draw. Does that sound? This could be the basis for some kind of interesting game. And that's part of the fun of Blinks is that you make these behaviors, and then you often find a game inside of that. Oh boy, a lot more suggestions.
Got some more suggestions coming.
A snake-like game where you have 4 blinks for controllers. A rock paper scissors. We've made there's some interesting rock paper scissors experiments we've made, and actually one that got made at last year's Global Game Jam that was really cool.
That's it.
Yeah. Oh, we could definitely make a really cool Game of Life. Well, let me first start by making this step through Game of Life thing, because that's something that I can do relatively quickly, and it'll show you how quick you can do something like this. If nobody minds, because this is going to be fairly programming intensive initially, I'm going to switch over to working in Arduino. I'm more used to it, and also I will also then test this on a real blink instead of the simulator for now, just to see what it looks like. So, and John, you're gonna have to watch the chat because I'm gonna be focused on making this.
I'm gonna watch the chat.
Yeah.
I'm gonna be the person. I'll describe what you're coding.
Yeah, and I'm sorry, everyone. I'm gonna adjust my camera slightly, which means you will get to see that my phone is held up by Legos. Oh, it's not in the shot anymore. Yeah. All right. Yeah, there it is. My second camera is held up by Legos. Don't worry about that. Okay. So, to start this, I want to do what is sort of a basic communication loop. This means that the blinks are listening to all their neighbors, and they're listening for the word, in this case, go, for someone to say next, next, next. Okay? So I'm going to call that, we'll call it communication states. So I'm going to make an enumerator of communication states, and I'm going to call it inert, go, and resolve. Why I need resolve will become clear as we do this. And then I'm going to make a byte called communication state. We're going to set it to inert. Everyone's going to be cool. And then in the loop, I'm going to make a switch, and I'm going to do communication state, because they're going to have different behaviors in each state. And I'm going to do case inert. It's very strange to have people watching you while you're coding. I've just realized how many typing mistakes I make. Never noticed that when I was by myself.
We also got a suggestion for a whack-a-mole game, which is great because we can just go wham.
Yeah,
and the code is.
Yeah, and that's the one that's got Game of Life built into it in a really weird way. I'm gonna resist the urge to build out separate functions right now. Or no, I'm not. I don't know why I would do that. This again, what I'm doing here is sort of our typical coding style. This, if you look at the source code for a lot of Blinks games, you'll see this basic premise that there's a switch in loop that throws to individual loops for each game state. You are not required to program this way. This is just kind of the way that we've done it. But there are some games on the platform made by developers that look nothing like this, and they work fantastically. This is just the way that I like to do it. So, in Inert Loop, I am going to do this. I'm going to listen for two things. Listen for clicking. That's something we need to know. And listen for neighbors telling us to go. These are the two things that we want to know in Inert Loop. So clicking is easy. We already know clicking. If button single clicked, I'm going to do something. And in fact, I'm just going to type it here. I'm going to set communication state to go. So I'm now going to broadcast the word go. We'll get to broadcasting in a minute. But my communication state is now go because I've been clicked. Now, if I'm not the one who's clicked, but my neighbor is the one who's clicked, how do I know that? Well, I first have to do a couple things. We're going to first do my favorite convenience function. This is a function that is built into the Blinks library so that you don't have to write the same for loop 1,000 times. This is for each face f. And f is just a variable. I could make this, L. But, we tend to use f because it's easier to remember. This is just a little pre-built for loop that runs through face 0, 1. It runs through 0 to 5. That's all it does. And so I use these everywhere because I don't like writing for loops. Who does? So in this loop, the first thing I want to do is there a neighbor on this face? So I'm querying a face, let's say face 0. I have to know if somebody's even there. And so there is a function called isValueOnFaceExpired. Now, John, you might want to explain this one because it's a little bit more technical than some of the other plain language functions. Yeah.
And it is value.
I fixed it. I was just typing it.
Okay. So the communication between blinks happens many times a second. You can think of when you say, I don't think you've actually used the function yet. Set value sent on face.
I have not yet.
Okay.
I can actually. I can put it up here.
Before we can think about, well, it would make sense. Yeah, exactly. So we're going to send our communication state, right?
Yeah. So that is the phrase that these blinks will be shouting at all times on all faces, every frame. They are going to say this thing, and this thing is inert, go, or resolve, which, because it's enumerated, is the number 0, the number 1, or the number 2. And that's just what they're shouting into the wind.
And so when we're listening for that, when I've got one blink here and another blink next to it, one's shouting 1, 1, 1, 1, 1, and the other one has to listen for it. So I'm going to look at all 6 faces. That's what Dan's doing here, looking at all 6 neighbors. And then is the value received on face expired? If that received value hasn't been heard in a certain period of time, it's going to assume that there's no neighbor there.
Yeah. So is value on face expired?
But you should correct that function because it's not orange.
Sorry. Yeah. Is value received on face expired? Has this technical meaning of I haven't heard a message in X amount of time. Functionally, the way we use it is that means is there no one there? And so by putting an exclamation point in front of it, I'm asking for the opposite. So is there someone there? So this is the function I generally use to mean a neighbor. This is my hey, there's someone there function. So if there's someone there, I'm going to take some action. So I'm looking at every face, and I say, hey, is there a neighbor on this face? Yeah, there is a neighbor on this face. Then I'm going to say, what is this neighbor saying to me? Is this neighbor telling me to go? Right? Because that's what we're here to find out. Oh man, sorry, this is really tripping me out because the cursor's on my screen twice. Okay. Is this neighbor telling me to go? And I'm going to ask another communication question is if is or nope. John, I didn't realize how often I get these wrong. No one's ever watching me do this. If get last value received on face, F again, is go. Right? That's a question we've asked. If get last value received on face, F, which queries that message on that face, and takes it in, and is it go, then you know what? It's time for us to go as well. We've been told to go, so we're going to go into go. Everyone just goes into go the moment they hear it, right? So in Inert Loop, we've done two things. We've listened for clicking, should we go into go, and we've listened for neighbors telling us to go, right? So now, presumably, we are in go state. So we need to make a loop for that. So we're going to call it go loop. And I'm going to make it down here. Void go loop.
And I'll just call out real quickly, if you're opening up a developer kit, and this is your first time loading them up, when you open up Arduino, there's, in the quick start instructions, the way to install the Blinks hardware type, and it's nice and easy to install, so it should only take a couple minutes.
So in go loop, we're not going to listen for clicks because it's just like go is sort of a temporary state. It's like a moment where something happens. All go loop needs to do is eventually go back to inert. But before it does that, it has to go into resolve, and this is for what I'll call rock, paper, scissors reasons. If you had go push into inert and inert push into go, they would just like bounce off each other infinitely, and there would be no safety. This is a sort of communication security thing. This is something I had to learn when I first started making Blink stuff because I was so used to this Unity stuff or just like general top-down programming where I just commanded a thing, just do this. And communication is not that simple in a distributed network. So this is pretty simple. You'll find this concept in like every Blinks game, and once you learn how to do it, you can almost copy-paste these things like verbatim into any game that needs it. But in go loop, all I need to do is like if all of my neighbors are in go or resolve, I can be resolve. That's all it is. I wait until there's no inert left in my neighborhood, and then I go to resolve. This is to prevent messages bouncing back. So I'm going to put this together really quickly. It's very similar to this one above, so similar that I'm actually going to copy-paste this face loop. And there's a lot of that in making Blink stuff. So in this case, going through each face, I'm looking for neighbors, and then I'm looking for neighbors who are in inert, because inert is the only state I don't like. So if I see a neighbor in inert, I want, this is kind of a funny one to explain. At the beginning of the loop, I am going to assume this is all going to go well, and I'm going to set myself to resolve. I'm going to just assume that I'm not going to find anything I don't like, and I'm going to go to resolve. And then this whole function here is just to correct for my mistake. If it turns out I have a neighbor in alert, whoops, no, communication state equals go. This is all go loop does. If you go into any game that we've already programmed, which by the way, you can actually get in the examples, because of the way this is cropped, you can't see it. In file examples, you can look at all the source code for all the first 12 games. The source code for the next 15, 17 games is all on GitHub. So you will see this function over and over again if you scrutinize our code. And that's all go loop does.
And in the comments, I see Jeff pointing out that, like, yeah, this specific concept is something that he's working through. He said, this is my big problem learning this concept. And it's interesting because not all games need to do this. It's a concept that allows you to have a game state shared amongst the board.
It allows you to broadcast.
If you want to count turns, let's say, you want to count the number of turns that are taken, then you'd want to use something like this. Or if you want everybody to do something at the same time in a discrete fashion, you'd want to use this concept. But games like Fracture, for example,
they don't need this.
Never need to worry about it. Or a game like Barry doesn't need to worry about it.
Many games just use this get last value received and get and set value sent to just understand their neighbors. That guy's blue, that guy's red, this one's off, and that's all they do. They don't broadcast messages. But we're making a broadcast game because I think it's interesting, and I'm looking at the time now, and I realized I'm gonna move quickly through this. So that's Go Loop. It's real nothing. And then we're going to go into Resolve, and we're going to make a Resolve loop. And Resolve is also kind of nothing. It doesn't do a lot. It pretty much does this. It's just there for safety. So Resolve loop, I'm just straight up going to copy this. Resolve loop. It wants to go back to inert. That's how it would like to end its day, by going back to inert. But if any of my neighbors, if any of my neighbors are still in Go, don't go inert. So in this case, if I see a neighbor in Go, I stay in Resolve. I can't go back to inert because he's in Go and he'll send me back to Go immediately and we'll loop around and it'll be horrible. So Go loop, Resolve loop, functionally the same, just looking for slightly different things. And I suppose you could modularize this into a sort of communication loop and you could feed it things, but they don't take up a lot of space. Oh, I need to save this. Oh, I'm sorry. Hold on. I just tried to compile this, and I've never saved this. We're going to call this... What are we calling this, John?
It automatically saves it on the date, which is nice and easy.
I could save the date. I just thought I would come up with a name for it.
Game of Life.
Shuffle of Life. Because of the card draw. I'm going to call it Shuffle of Life. So I'm compiling this. See this compiler's running, doing compiling things. It's a very small program. I've only used 36% of program storage, and I think the base code takes up like something similar to that. So I haven't really done much.
Can we show people what this looks like by making these different states a specific color?
Yep. So normally I do like a whole display thing. I'm gonna make this easy. Set, color, we're gonna call, what do you want? What do you want for inert? White?
Yeah, we could either, sure.
We'll do white for inert. And in Go, we're gonna do red because it's exciting and visible. And in Resolve, which again will only be there for a moment, we're gonna do blue because it's the color of peace and resolution. So, we've got these loops running. We've got the value sent on all faces. White, red, and blue. I don't know if this is gonna work. Probably will. But I'm gonna switch cameras to my blinks. Hooray. Turn them all on. And then I'll go back real quick. This is the compile button that I used to just make sure that everything worked. But right next to it is the upload button. And when I click that and then rapidly go back to my blink scene, that'll run. And then at some point you will see this blink go into teaching mode in like a moment. Sorry, I can see the blinks, the Arduino screen. There, okay, went into teaching mode. Oh man, it got a lot lighter since I set up this camera. Hold on. Bear with me. Okay. Sorry, it's a little dark, but it'll make the blinks easier to see. And there we go. We've got these white blinks. Now, I'm going to test this by itself real quick. If I single click this, it should briefly go into Go, and then Resolve, and then back to inert. Wow, that is fast. It does happen, but it's really fast. Let's see if it communicates. See if I've done this correctly the first time. Okay, was that visible? Is it visible to you, John?
Yes.
Okay, so they are all going
very
really, really quickly. Go resolve, go resolve, go resolve. And so we are now getting these blinks as a crowd to step together, which is really cool. I mean, this is the basis of what you could make as a game of life, right? And now we just got to put in what happens on each step, right? And so just because of time constraints, I'm not going to build a game of life. But I will build this shuffle idea that it like draws cards, basically. Or not even shuffle. I'm just going to build something that I think could be useful. Real quick, here's what I'm going to add. I'm going to add this. I'm going to make a variable called card hue. Card hue is going to be 0 right now. What I'm going to do is each time it gets that go signal, it is going to set the card hue to a random value between 0 and 255. I realize this is not like drawing from a deck, but it'll have an interesting effect. So in this moment, when it goes from inert to go, or actually no, I'm going to do it here. When it goes from, in go loop, I'm sorry, this is just me trying to make a decision. When it goes from inert to go, either by clicking or by message, I'm going to randomize that color. So card hue equals random 255. Our random is inclusive, so it's 0 to 255 inclusive. That could be important if you're doing smaller numbers. This also happens here. All right, make sure I didn't break anything. And then, John, should I not do the fix for this so we can see its outcome, the random thing?
Right.
I think it'll be interesting to show people that. And then the only thing I need to change is that in Inert Loop, instead of set color white, I'm going to use one of our color functions. And this is really cool. We've got multiple, but there's two sort of major color functions for making your own colors that are not just red, orange, yellow, green, blue, violet, white, which is make color, in this case, HSB, hue, saturation, and brightness. There's also a make color RGB, red, green, blue. In this case, I'm going to use HSB. Hue, H is hue. For us, that's going to be the card hue, because that's the thing that we're randomizing. Saturation, I'm going to put it to maximum, 255. These scale from 0 to 255. And brightness, I'll put it to maximum, 255. So now, it's going to be some random color when it's in Inert Loop. These are still going to be red and blue, though, these two. And actually, I'm not going to do that. I'm going to make them off so it's a little bit more noticeable. You won't be able to see the differences between them, but I think it'll make it more noticeable on the blink itself. So all I've done here is make the Inert Loop show this generated color from a card hue, and I've randomized a card hue in the go when it turns to go. So I'm going to install this now, and while you can see it's doing its thing down here, doing that, and I'm going to switch over to the Blinks camera, and at some point this guy will come alive, and there we go, and it's teaching. This is amazing. Like for newcomers, as far as you're concerned, this is how Blinks work. As someone who's been working with them for 3 years, this is not how they always worked. They were not this quick before. It is so amazing to be making games with this developer kit. Yeah, it's great.
When we started it, you had to program each one individually.
Yeah, if I wanted to test this on 6 Blinks, I had to program 6 Blinks. It was fun. So these are all red. That seems weird, except you remember, I'm going to go real quick back to Arduino. Whoop. Our default card hue is 0, which is red. So these are all red right now. Now, if I click, it should go through that process of randomizing the colors. I'm going to make a little line here, and I'm going to click. weirdly, they all turn the same color, which doesn't feel very random, does it? And this was something that bugged me. I didn't understand what I was doing wrong. This was early on in my process of working with blinks. This is important. Just like in a more traditional sort of like, C++ or something, you have to seed randomness or else you get the same thing every time. You have to do that here too. Randomness will be predictable unless you tell it not to be. I know that seems weird, and I had a whole argument with our with Josh about it, but he is right. This is the proper way to do it. So I'm going to go back to Arduino, and I am going to fix this. And the fix is really simple. It's just the word randomize. I just put randomize in the setup, and now I'm going to get truly random stuff. And just to make it clear, I'm going to do this randomization card hue inside setup. So now they're going to start at a random color as well. So let me install this. Go back to our blinks.
And I think, I don't know if any of our games have taken advantage of the fact that all blinks are seeded with the same random sequence
Not
without
yet, but
random.
they could. Somebody should. It is fascinating, and it was very confusing when I first started making Blinks games. I didn't know that. I mean, this was, 3 years ago when I was an intern? So now I've got these random colors. If I click, I get all sorts of colors. I'm asking it to just step, 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 step. Now the logic I put at each step is dead simple. I just randomized a color. But you could put very complex logic at each step. You could make a game of life this way, and we have made a game of life this way with steps. Something that, I know we've got about 15 minutes left, and I want to make sure that I can answer as many questions as possible. But something I could add to this really quickly is instead of button click doing the stepping, I could have a timer do the stepping. And then it would go like a auto run game of life. But I'm not going to do that right now because it would take me a little bit, and I want to make sure there's time to answer questions. So I realized this was kind of a whirlwind, but what questions from the chat?
Yeah, I mean, I would say keep going, and I think people are free to ask questions, and I'm monitoring the questions.
And I want to point this out, that this is just the hour that we're going to be on television. It's a pandemic. You're in my kitchen. I can't leave. I am going to have Discord open all day while I watch the season 2 of The Mandalorian, probably. And so you can ask me. I am going to be on the Playcrafting Discord in the Move 38 channel, and I'm going to be in the official Move 38 Discord channel as well. So you got more questions, I got more answers. I will be here all day. I'm basically committed to being at this desk until, I want to say like 8 p.m. So I'll answer questions for the rest of the day. This is just my hour of TV time. So should I make the timer? Does everyone feel like that would be interesting to see the timer?
Yeah, and are we doing anything Game of Life-like here?
Not yet. I thought that would sort of take a little longer, but maybe I can do that instead of the timer?
Either way is fine. I think, yeah.
Okay, well...
The timer's kind of nice because it does...
it'll also Yeah?
The timer's an interesting one because you want them all to step at the same...
I'm going to cheat the timer. I'm going to have it double click. Here's what I'm going to do. I'm just going to say this so everyone knows. I'm going to have it so if you double click a blink, that blink is the driver. That blink sends out the pulse on a timer. Does that sound fine to everyone? It is kind of cheating. But
so yeah. Dan's creating a master blink, which hey, you can do.
Yeah.
But if you want to make them all synchronously update together,
you can use this code
we have
exactly
examples
as
of
is.
code that show how to use.
And this code as written absolutely allows that. You do not have to change anything about this inert go resolve code to have synchronized time, and they will synchronize each other. If you pull one out of the loop and put it back, this will. WAM works the exact same way. WAM has everybody's timer is running at once, and anyone can be the leader. But I want to do the double click thing because I think it shows another interesting function, and I'm going to try very hard to do it in 10 minutes because there is another workshop at 11, so we got to stop going live in 10 minutes. So, John, you could vamp over this, but I'm just going to code and talk sparingly.
Awesome.
Let's see. So, in the main loop, I'm going to do the double click thing in the main loop. I don't want to do that in just inert loop. I'm going to say if button double clicked. Oh, I've typed it wrong. Super cool. Make a boolean called amTimer. If I'm the timer, this is going to be true. If button double clicked amTimer equals whatever it wasn't before. So if it was true, it will become false. If it was false, it will become true. Is that everyone square with that? Great. I'm going to make a timer, which is a type of... God, is it a variable? What is a timer? I don't know enough about programming. What is a timer? It's a function?
Yeah. Timer is a custom type here. I guess.
Yeah.
And it has some, instance member functions.
Oh, I've just crossed 100 lines of code, by the way, which you can tell because this bumped out. Sorry, I always notice that when I hit it. But there's 99. There's 100. Anyway.
The little things.
Yeah. You never want to bump it. Yep.
So timer has a couple of properties that are really useful, and the reason why we created timer was if you don't use timer, you can always call for the millis or the milliseconds that have passed since you've put a battery in the blink. And I like to use millis for quickly working with time, but the timer has a bunch of nice conveniences. And you can think of the timer as kind of like an egg timer, where if you turn the knob to 60,
or 600 in this
it
case.
will, or 600, and 600 will tick down 600 milliseconds. So it'll be
it will ring
6
forever.
tenths of a second.
Right. So in this case, I've made a timer, and then I've defined a amount of time that I'm calling the step interval, and that's 600 milliseconds, so 6/10 of a second. Now, I don't know where to do this. Let's say
Why not 1 second?
Because I'm just weird. I don't know. Let's just say 1,000. You're right.
Yeah.
So I'm also going to do this in the larger loop. If amTimer, so if I am supposed to be the timer, you know what? Yeah. If I'm supposed to be the timer, then I need to be like, is the timer expired? That's a question I can ask. If step timer.is expired. That will return true if the timer is expired. Just a fun fact, it returns, so this timer has never been set because it's not set anywhere. So in the first frame, the timer will register as expired. I know that could be it's a slightly sort of semantic problem. Not expired, it's just never set. But if it's expired, I'm going to, I should reset it. So I'm going to say step timer.set. What is it? Step interval. Now you can type a number into here. I could have typed 1,000. We find that it's great. It's much better to define it so that later you can, if you use it multiple times throughout the program, you can just tune it up here and be like, everything's moving a little too slow. Can we just set this to 500? You know. So I am setting the timer to step interval, which means it will not expire again for 1,000 milliseconds. If it's expired, I want to set the timer, and then also I'm going to set myself to go. That means that's essentially like getting my button pressed. Is it communication state? I've forgotten how I wrote this. So this is going to function identically to having my button pressed. And remember, this will only happen for one frame, because the frame that this evaluates to true is expired. I'm immediately going to set it for 1,000 milliseconds. So I am going to set myself to go here. That's it. That's the whole thing. Let's just make sure it compiles before I embarrass myself. Great.
You're doing great, Dan.
Yep.
Live Coding Pro.
And I'm going to switch this to the Blinks window.
I feel like the peanut. We've got the fans in the audience. I think everybody's impressed by your live coding skills as well.
We've only got 6 minutes, so.
Those looking off to a good start.
Yeah. Can I just say this? I have this. I've never really streamed, from my computer. I got OBS and stuff, but this program for Android called DroidCam OBS. So really, John, you had a similar one on Apple that worked really well for you. It's like that. So everything still works. I can still single click to move these forward, but if I double click this one, you see that he's just like flashing by himself. Oh, is he? Oh, he is. Yeah. Okay. Why is it staying pink though? Oh, there's mysteries afoot, John. So, if I double click this again, timer's over. It's no longer doing that.
Because I don't actually think it's going through the inert loop.
You are absolutely right. John has so this is the great thing about debugging on Blinks is just you're staring at this little hexagon and going, why isn't this changing color? Everybody else is changing color. John is absolutely right. If you look, I randomize the color in Inert Loop, and this is never going to Inert Loop. So I need to randomize the color here. Obviously, there are much more efficient ways of doing things. I'm duplicating code all over the place here, but we're not hurting for space. I'm not trying to show off.
You have to think like a Blink.
You do. That honestly was the hardest thing for me. It wasn't the programming. The programming was, I had done C# and C++ and a little bit of Objective-C. The syntax was easy. The library was dead easy. Making things that were simple, I could do, even in my first week of the internship, I could do in an hour. It was the intellectual part. It was oh, how do these speak to each other? And how can you make interesting games with them? That was the part that took me months. Not the technical part. The technical part took me, you remember, it's the first week and all the interns were making stuff.
Usually in the first day you can get up and running and there you go.
So now it's not doing any game of life stuff, I realize, but this Blink is setting the pace for everyone else. And what's really interesting is I could do this. I'm going to do something, and I want to show you that this code should be pretty flexible. Okay. No, wait. I want to get these...
The timer's desynced?
I want to get them just kind of not on the same page, but I keep accidentally...
You could
okay, see, all right. No, here, look. So now they're kind of on different timers, and yet the code is fine with this. It is happy to take commands from two desynced timers because that message security is in place so that it can't conflict. And so now we've got a double speed thing because it's this. And this is one of the cool things about Blinks is realizing this is an interesting behavior. Two timers driving the same flock of Blinks. Could that be the start of a game idea? And that's really, I think, not to get philosophical about Blinks, but I guess that's my job. That, to me, is the essence of making an interesting Blinks game, is to first start with an interesting behavior. That you have to think like a Blink, that Blinks have behaviors, and that you then work together to make games out of those behaviors. As opposed to trying to think top-down like you're working in any other game development program where you're God and you're just making commands. Remember that each Blink is thinking for itself, and that imposes some difficulties in some ways, some of the stuff about communication which seems complicated, but it opens up this extraordinary world of swarm behavior and unintended organic consequences. And to me, this is fascinating. I now want to figure out what can I do with asynchronized timers. Sorry, I'm turning them off. So we've got 30 seconds left. So John, if you want to sign off, say thanks to everybody.
Yeah, let's do our wrap. Throw us back to the main screen. first of all, thanks so much for joining us, everyone. Dan, you ran just an awesome workshop. It looks like people were learning some great techniques for getting all your blinks in the same with the same knowledge. If you're curious to learn more about blinks, you can check us out at move38.com. We're live in shipping blinks and developer kits. We're also going to be around this weekend, as Dan mentioned. Find us on the Discord for Global Game Jam, and we'll be helping you make your first game or your latest game on Blink.
And I was going to say, if you're new to this, don't worry if I don't respond immediately, only because we've also got some of like the best and like most experienced members of our dev community also tuning in this weekend. Also, they're answering questions. I want to shout out to Fredicus. I don't know if he's watching this, but he's been answering pretty much as many, if not more, questions in the Discord than I have. And he's just a member of our developer community. So everyone is here to help you, whether it's me, John, or the hundreds of developers in our community.
Awesome. So thanks so much, and a huge shout out to Playcrafting. Thanks so much for letting us stream on your channel today, and looking forward to communicating with all of you in the future. So we'll see you soon.
All right. See ya. Okay.